I'm going to do for 15 is I'm going to record it, and all of them, let's solve them all for y and get the equations, then we'll go graph them all at once. So hopefully that will cause less issues. So for 15, x plus y is less than or equal to 4 is one equation. So let's just go ahead and solve it for y. Subtract your x from each side. Y is less than negative x plus 4. Yay, that one didn't take too long, right? We'll graph them all at once. That way I can just pull up a piece of graph paper and not have to erase a bunch of stuff. The second equation on 15 was 2x minus y is greater than 6. And so if we go to solve that one, we could scoot the 2x to the other side. Negative y is greater than negative 2x plus 6. And then what will I do now? Megan, do you know what would I do now to get that one? And that would mean I need to, so it would be y is less than, and we could just change all the signs on everything. That'd be the quick way to multiply by negative 1. We just got to flip that inequality sign. So I'm going to have to graph in a minute this one and this one. And I'm just going to do them all at once. We've got one more we need to solve for y if it's not already. And it's not, of course. X minus 2y is, equal to 8. Okay. That's interesting. I've never seen a book give so many different types of problems like this. Usually they stick to just the basic type. So this is definitely, this is an equality. It's an equal sign. So that means we're just going to graph that line. We still need to subtract x from both sides. Negative 2y is equal to negative x plus 8. And when we divide everything by negative 2, no flipping the sign because it's an inequality. It's an equality. It has an equal sign, so it kind of seems weird not to be doing something now. But that's going to be x over 2. Wouldn't that be the same thing as saying 1/2 x? Okay. And then 8 divided by 2 is negative 4. Okay, here we go. So the first one we're going to graph is y is less than negative x plus 4, and I'll do that one in blue. Trying to cram it all on the margin, and I can't. So what's our y-intercept? 4, and my slope is the number in front of the x, which it's the imaginary or the invisible one that Lay's math guy doesn't write. So our slope would be negative 1 over 1. So we would rise negative 1, which means go down 1, run 1. So it's basically, if you kind of look, you're going to be hitting a diagonal down all the way. You could count it carefully, or you could just do this. So I'm going to put that in. After I dot it, am I going to draw a solid line or just leave it dotted? Solid. Was there an equal sign under that one? There was? I didn't copy that down for sure. Okay, so solid, good, okay. And then y is less than or equal to negative x plus 4. Am I going to shade above or below? No, it'd be below, wouldn't it? And again, I could use the test point. If I plugged in y is 0, I would have 0 is less than or equal to negative x is 0 plus 4. Is 0 less than or equal to 4? Yes. So 0, 0 was in the area where the solutions are, or we could just shade below like we said at the very beginning. Just want to make sure I put a test point on a video in case I don't remember what I did over the weekend. Okay, so now we need to graph the next one. I'll choose like red, I guess. Okay, y is less than 2x minus 6, and there's no equal sign under it. So what our y-intercept is, negative 6. So graph your y-intercept. I know, it needs to take a while. So y-intercept is negative 6. Let's put that here. Still got 5 minutes, so don't put up yet. We're going to get this done. Up 2 over 1. Slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1. You know, what you can do, get some good points, and then if you're just trying to speed up the process a little bit, do this. You just, try to finish the line out if it takes forever to count off each point. Now, y is less than 2x minus 6. Let me write that down. We want to shade above the line or below the line? Below, yeah, y less than, we can read that as y below the line. Below the line would be like down here. So I'll do that real quickly.
It's not solid. Oh, well.
It's not what now?
It's not solid.
Oh, did I mess it up? It's not, okay, so yeah, normally if I was doing this on a board, I would go back on that red line and erase a little piece in there. So what I'm going to do to show my eraser dotted part is come back and do this. If you're using a pencil, it's easy to kind of change that just by erasing pieces. So pretend I just erased those. All right, we got one more thing to graph, and it's actually a line, y equal 1/2 x minus 4. I'll do that in green. There's no shading on this thing because the y-intercept's -4, and it's just the line. So if I count the slope, it's up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And so I'm going to just draw this line here. I've never seen a book give a problem like this, so this is definitely being very thorough. Where are solutions going to be here? Well, I'm going to color them in on yellow. Where do you see all of those graphs having any points in common? This is a surprise. Huh? Well, don't they all intersect in this point right here? And also down over here, that green line is what's making everything different here. If you look at the solutions as what the red and the blue would be overlapped, but then you put the green line on top, it's just going to be where the green line, oh, it's actually more than that. Are there other points that are where the green line and then the blue and the red are overlapping? Yeah, anything in between there, right? So in this case, our solution looks like that, and I have never seen a problem like that before, except in this book. So that's what's different. Usually it's a whole area you're shading in, but because they gave you that line, the points on the line that fall in that blue and red overlap area are the solutions. Just so you know, had this problem had that last part left off with the line, where the solutions would be, just so we can clearly, make sure you're getting this, where the solutions will be, if it had just been the first two equations and not the line, would have been where they overlapped, and I would show that by doing this if that had been the case. I would have shaded in all this part where they overlap here. Solid, and that's how you would have shown your solution set. Again, there's nothing to write down. The graph is the work. So that's one of the reasons why it's really kind of hard to use the calculator to do this, but you could check your answer to see if you've got the shading right. And we'll do that a little bit tomorrow when y'all come in. We'll take one, and maybe one that y'all have a question over, and do that on the calculator. But we are out of time.